Hello everyone, welcome to this session on synthesis and Verilog coding styles. Now we will see one important switch in Verilog, how to use looping constructs and how to use looping constructs to generate hardware, how to use looping construct to simplify the hardware we are going to develop. Okay, so mainly we are going to use looping constructs. Okay. So in looping constructs in Verilog, there are very important point we need to keep in mind. There is a for loop and there is a generate followed by a for loop. Okay. This is used in always block. Okay. Please note this is used inside always. This is used outside always. We should not use this in always. This should not be used or cannot be used inside always. Okay, this generate for loop, this is used for instantiating hardware. Okay, this is very important. We will see the details also in, we will see both of them in detail with lab also. We have a separate lab for both of them in detail to understand. Okay, so we are going to see, let's say for example you want to instantiate a hardware multiple times for whatsoever reason. Let's say you want to instantiate a AND gate 100 times, or you want to instantiate a OR gate say 500 times for whatsoever reason it may be. Then you will use a generate for loop. Okay. Whereas the plain for loop used in always, this is used for evaluating expressions. Okay. This is not for generating, means generating in the sense instantiating a hardware. See, at the end of the day, this will result in a hardware, but it is not meant for instantiating some other hardware. Like say you want to instantiate a AND gate 500 times. This is not meant for that purpose. Whereas if you want to evaluate an expression repeated times and see what is going to happen, then you use a for loop. I will give you an example for both. Okay. So as an example, let us take, for example, we want to build a 4:1 mux. Let's take 2:1 mux. Okay. So this may not be the best way to write 2:1 mux, but for sake of argument, I'm going to write it this way. Okay. So always at star. So I'm going to say begin case of select. I will say 1 tick B0. I will say y is equal to I0. 1 tick B1, y equal to I1. End case, end. Okay. I'm sure this is not the best way to write it, but for sake of argument, I'm going to write it this way. 4:1 mux if you want to write it. Always at star begin case select 2 tick B00, say y equal to I0, 2 tick B01, y equal to I1, 2 tick B10, y equal to I2, 2 tick B11, y equal to I3. End case, end. Say for example, we have to write a 32:1 mux. Now if I write it this way, clearly As the complexity grows, this is the best way to write the mux, correct? Because 2:1 mux can be written in one line, something like this: assign y is equal to select colon I1 colon I0, correct? This will make the same 2 cross 1 mux. So this looks a very bad way of writing a 2 cross 1 mux, whereas this looks like a most elegant way of writing the 2 cross 1 mux. But when you come to 4 cross 1 mux, or when you come to 32 cross 1 mux, you cannot write it this way. We cannot write it this way here for sure. So writing it this way seems to be a good option, right? Yes or no? Because if you try to write it this way, it will not at all be readable. It will become very confusing, and it will become not at all readable. So if you try to write it this way, always at star begin, then you have to say case select. Now you have to write for all the 32 conditions: phi tick b 0 0 0 0 y equal to I0, phi tick b 0 0 0 0 1 y equal to I1. Like this, you will write it for all phi tick b 1 1 1 1 1. You will say y equal to I31. End case end. Now slowly this will also, this is very readable. From a readability point of view, this is very good. But from the code point of view, this is going to get complicated as you start writing more and more. If there is a simple way to write it, then it will be better, right? So let us use, this is where we are going to use the power of blocking statements. We are now going to use the power of blocking statements here. We are going to use blocking statements in the most meaningful way. Correct. So let's see. Suppose if I write this way, always at star begin. Okay. I have an integer I. So I say for I equal to 0, I less than 32, I equal to I plus 1. This is just like the same standard for loop like C. Begin. If I is equal to select, Y is equal to I of or input of I. Okay, I'm assuming input is a 31:0 bus, and out of this one line I am selecting, it's a 32 cross 1 mux, correct? So one line from this I am selecting here. End for this for and end for this always. That's it, we are done. This is a 32 cross 1 mux. So simple and so elegant and so beautiful. Now this is the code for 32 cross 1 mux, correct? Suppose if you want to write a code for a 256 to 1 mux, anything will change? Simple. Make this as 256. That's it. My assumption will be input is a 255:0 bus. That's it. My input is available like this. I am done. If the value of I matches the select, then Y is input of I. That bit corresponding to, that means what? Whenever I and select are equal, the value of that bit index of input is my output. That's it, correct? So Y is input of I, correct? Correct. So whether I need a 32 cross 1 mux, 256 cross 1 mux, 1024 cross 1 mux, doesn't matter. This becomes very simple and elegant way of writing it.